Okay, so in this video, we're going to take a look at electromagnetic induction. So the things that we've got is I've got a pretty strong neodymium magnet here. And inside here, we've just got lots of conductor all wrapped up into coils. And they're wrapped around here. And you can see it shows you which way they're wrapped. So they're wrapped around in this direction here. And what we've got here is a very sensitive ammeter that we're going to use to measure whether there is a current flowing in this coil or not. Now, the first thing to note is nowhere here is plugged into any electricity, and just so you're doubly sure, see, absolutely nothing plugged into the mains. Okay, so this is all being created simply by the interaction of this magnet with this coil here. So let's zoom in a little bit closer so we can actually see the ammeter a little bit more clearly. So what I'm going to do is I am going to move this magnet into this coil here. So okay, so let's do that. So you know when I've moved the object into the coil, so what you saw, so let's redo that. So we're going to come from above and go into the coil and then become stationary inside the coil. So you can see nothing is happening with the magnet here. Okay, so let's move it in. And you can see that the ammeter deflected to the right, so we measured a current. Now you'll note that the magnet is now inside the coil, but it's not moving. So when the magnet isn't moving, we get absolutely no current. So no magnet movement, no current. When I moved the magnet into the coil, we got a deflection to the right. So what I'm now going to do is pull the magnet out of the coil. So you saw there, we got a deflection to the left. So the direction of movement of our magnet seems important. So if we push it in, it goes to the right. If we pull it out, it goes to the left. So I don't know which pole I've actually put in there because these magnets don't show you on them what the north and the south pole is. But what I'm going to do is I'm going to flip it over. So we're putting the opposite pole through. So if we put the opposite pole down, we can see it deflects to the left instead of the right. And now if I pull it out, we'll expect it to deflect to the right. And it does. Okay, so we've got a couple of key things there. If we want to induce a current in our coil, the magnet has to be moving. If we change the direction that the magnet is moving, we'll change the direction that the current is induced. And if we change the pole that we move towards the coil, we'll change the direction that the current is induced. Okay, so that's a few things so far. So what I'm going to try and show you now is a really slow movement and a really fast one. So I'm going to start it inside here. So let's let it reset to 0 once it's stationary. So I'm going to pull it out quite slowly. So you can see there, we got quite a small current when we move the magnet out quite slowly. Let's repeat that, but now I'm going to pull it out really quickly. Okay, so let's let it settle. And you can see that the faster I move this magnet, the larger the current that we induce in our coil is. So this is just a nice little demonstration of a few key things. So the last thing I want to show you is what happens if we let the magnet fall all the way through our coil here. So let's do that. So hopefully if I drop this correctly, we should let it fall all the way through. Okay, so let's run that one again. So make sure you can see it. So watch very carefully on your coil. I missed the coil. Amazing. Okay, so that happens quite quickly. So just to explain what you should have seen there, so you can rewind and have a look. You should have seen the ammeter deflect one way and then the other. Because to start with, what's happening as it falls is our magnet is entering the coil. So we get a deflection in one way. So when we enter the coil with this particular orientation, we get a deflection to the right. If I then let it come out the other side, this magnet is now leaving the coil. And so we get a deflection the other way. So actually, if you let it fall all the way through, you see it deflect one way and then the other because it first enters the coil and then leaves the coil. And that's why we're getting that happening there.